For our second video, we're going to be solving equations by taking square roots. Now, for number 4, we already have x squared all by itself, so we can immediately just take square roots. And there are two of them. There's plus or minus radical 64. Just want to point out to you that there are some problems where you have a perfect square. The square root of 64 is simply 8. You're really saying what number times itself is 64? The answer would be 8. So you have positive 8 and negative 8. As you move to number 5, we can add a 2 to both sides. 19 plus 2 is 21. By the way, our ultimate goal is to get x squared alone. That's why I did that, adding the 2. Here I'm going to divide both sides by 3, and I will have x squared is equal to 7. At this point, now it looks just like number 4. I can go ahead and take my square roots. There are 2 of them, and 7 is a prime number. You cannot reduce that radical any further. We're done. As we move on to number 6, again, the big difference here, of course, is that you can see that we have a much more complicated expression. We have the x minus 1 quantity squared, so I'm going to get that isolated first. I'm going to divide by 5. I'll have x minus 1 quantity squared is equal to negative 4. And now I'll take my square roots. I'll have x minus 1 is equal to plus or minus. Whenever we see a negative inside of a radical, square root that is, we can pull out an I to represent an imaginary number. And the square root of 4 is actually a 2. So we'll have x minus 1 is equal to plus or minus. Now I'm going to put the 2 in front of the I. Now we're not done just yet because we need to get x alone. So we're going to add a 1 to both sides. It's very, very tempting to try to add the 1 and the 2 to create a 3, but these are not like terms. You're going to have 1 plus a 2i and 1 minus 2i. That's what this plus minus is really representing. And that's it for our second video.